Welcome to the Maintainable Software Podcast, where we explore the art of improving existing software with seasoned practitioners who have helped organizations overcome the problems often associated with technical debt and legacy code. I'm your host, Robbie Russell. On this episode, Ryosuke Iwanaga, who is a staff software engineer and the president of Ops BR. Ryosuke joins us from Vancouver, Canada, in North America, on planet Earth. Ryosuke Iwanaga, welcome to Maintainable. We're so glad to have you join us.
Thank you so much. I'm glad to see you.
So as you reflect on your experience in the industry, what do you believe are a few common characteristics of, dare I say, well-maintained software?
I would say the ownership is the pretty important factor to make the software or the system is maintainable. So the ownership is the thing I would say.
Tell us more. What do you mean by ownership? Is that all software projects have some owner that probably paid to have it developed, but what do you mean by that?
Yeah, so I would say maybe the single threaded ownership. So for example, the team or the member on your business application for sure, it's obvious. And then you might see there's some opportunity to create a shared library to make the other teams and also the your team very fun. You don't have to implement the same thing multiple times in the different teams, so that you create some library for your team and also you share that library to the other teams. And then the other team said, thank you so much, I will consume that library, and they are also happy. That's great. But a few months later, the other team said that, hey, I need another a feature to your library, and can you implement that feature as well? But at that moment, you have too many tasks on your regular job, your regular stuff, so that you don't have that. You don't have time, so that the other you request the other team to implement that one. They implement that, and you just approved, merged, and they are fine. But you realize that change breaks your side of the functionality, so that you need to fix something immediately after that, stuff like that. So why this happened? Because that shared library is owned by you or one of the teams inside the organization, and that's fine for some cases. But I saw many problems caused by this kind of structure, because the ownership in this case one team, but the library is shared across the team, and one team can't think about all the dependencies, all the edge cases used by the older consumers. So that's your team's main responsibility is your team's software or the application, right? So it's not the responsibility for the shared library. So in this case, the ideal world, you should have a kind of dedicated team or person to maintain that shared library. So that's one example to showcase the ownership is pretty important to keep it maintainable.
You touch on the scenario and the reality that a lot of teams are focused on their own particular projects, and maybe they're able to leverage this shared, use the example of this shared library within an organization, or maybe internally or externally of an organization. And there's just things needing to be improved upon it. And then it's we can go ahead and change it yourself. And then that potentially breaks other things for other people. And that could be problematic. And then what sorts of strategies have you seen taken to help teams realize hey, maybe there's an implied ownership, whoever last worked on this project, or you're responsible for, some teams will be make changes to something and you break it, it's your problem type of thing. But then that doesn't necessarily turn out to happen if your change breaks something in someone else's application. You're just completely unaware of it until they come back and be oh, what happened? What changed? So what sort of strategies have you seen teams take to address that sort of problem and to find an owner, or volunteer-based thing that you've seen work well, or a bit of I've seen a couple different strategies there?
Yeah, as I mentioned, ideally, the having a dedicated owner or the team who has a responsibility to maintain those kind of cross-team or cross-organization shared stuff. So that would be ideal, but it's difficult because it's additional investment in terms of the development resources. So I've seen a lot of times the kind of the voluntary team or a community-based approach, even inside the organization. It's kind of community-based, so that they might have some kind of like a one single person ownership, but the other forks, even cross team, can also contribute and maintain, like which is similar to the like a regular OSS project. But the sometimes work, but the again it's kind of voluntary stuff. So if the like main author has a very busy task in like a quarter, then it's pretty hard to like improve that software because the main author is too busy at that moment. So that could happen.
What is your current take on the metaphor technical debt? Do you use it very often in your day-to-day work? And if so, has your definition of it evolved, say, than from earlier in your career?
Yeah, so the tech debt, when I was in the AWS S3 team, some code, the last commit time was like 10 years ago. Right? So it's obviously like well working for 10 years without touching anything. But when I need to change something on that code, it's pretty tough because like, for example, there are no testing or like, yes, it's hard to find the right burst radius by changing that kind of software. So that's like a obvious and the simple tech debt in like a large system or like a longer legacy system.
Hey folks, it's me, Robbie. I want you to take a moment and close your eyes. Now picture your code and your applications as a symphony. Now to keep that symphony playing smoothly, you need an orchestra of tools. That's where our podcast sponsor, AppSignal, takes center stage. They combine the elegance of error tracking, the precision of performance monitoring, and the harmony of logging into one symphonic suite. Whether you're composing with Ruby, jamming with Elixir, orchestrating with Node.js, or harmonizing with Python, or maybe even a little bit of flourish of JavaScript, AppSignal's got the sheet music for you. And here's the crescendo. Plans start at just $23 US a month. That's gotta be music to your budget's ears. Plus they're certified ISO 27001 and they dance the GDPR and HIPAA compliance beats. So don't miss a beat, my friends. Head on over to appsignal.com and tell them that your good friend Robbie from Maintainable sent you. Now, open your eyes and let the symphony of smooth coding begin. Let's get back to our show. When you encounter those sorts of things, what sort of strategies have you taken to reduce the amount of technical debt? Is it just that things are, you mentioned like maybe zero tests or a lack of testing or not enough testing, but how do you go through and think about prioritizing what you should be working on when you're coming to that particular project, potentially because you're trying to make some change to it? I assume you're probably not just going to install it or try to get it running just for fun, just for no purpose. Yes, you're probably wanting to make a change. That's why most people clone a repository. It's either going to look at it and be like, learn from it, or you want to understand how it works. Maybe one thing, if the documentation doesn't tell you that, or you want to run it and maybe make some modifications to it. So in that scenario where something's really, maybe not been touched in a long time, maybe outdated on certain things, what do you think is a good, effective strategy to come in there and to not just get lost in the weeds of like, how many things should we update first? How do you think about starting that process?
I think the like dramatically changing that kind of legacy software is pretty too risky. So one strategy I would take is making more monitoring and alarming, more like an end-to-end type of style, not like focusing on the one level of the testing, but focusing on the like application functionality, so that you probably already have, but you might want to add more to verify that the functionality involving that kind of legacy tech that the software is working correctly. Right now, for sure, it should working correctly. And once you ensure that like monitoring and alarming, then like you have some relief to change something on that code or like replacing with the newer version, no matter, because you already know that it's working or not on live on like a metrics or like alarming. So I think that's a good strategy to tackle anything legacy.
What are some strategies that you've seen work well to help teams avoid regressions in their software projects? Is it like a very similar thing where you're going to lean on a lot more alerting and monitoring, or are there other types of approaches in addition to that?
Yeah, especially in Amazon, the change management is the my favorite one. So the change management means that when you want to change something in production, including like a deployment software or like just single configuration change or whatever, when you want to change in production, the people need to prepare the change management documentation before the actual change, and then get the approval. Get the review with the people and also the approval, and then you can do that. So it sounds like like a bureaucracy, but in reality, it's pretty effective, I would say. So let me show some example. So the reason why they need the change management is the most of the outage are typically caused by the change, like a deployment, right? Not the like a hardware failure or like a database disaster. Most of the failure are caused by the change. So the change is the most risky operation. So you need to prepare. The reason why is the human has the optimistic bias, so that the like people tends to believe that hey, my change is safe to go, so let's do it. And then in reality, you see the like a disaster or a worst case scenario in the production. So the practice for the change management is the doing that kind of practice like before the actual change, so in advance. So the way for the change management documentation is formed by like what is a change and why you need a change, obviously, and also the how to change. But the main part is to think about the worst case scenario. What would happen if you go pretty bad, even if you feel it's completely safe because you test it well, everything's fine, load test is fine, but think about the worst case scenario and then try to think about the how to mitigate that kind of worst case scenario or like how to address if it happened in advance. Because if you don't prepare that in advance and it really happened in the production, you will be panicked, right? And then you might cause the like another secondary outage by the like a quick hot fix or whatever. So the change management is the way to solve like avoid those kind of disaster by preparing before the deployment or with any changing.
And do you feel like that's something that every team should be thinking about, or is that more at a certain scale or a certain maturity point in a piece of software's life cycle? Do you think that those types of steps are most helpful? You mentioned like the bureaucracy of that. Maybe I'm air quoting that, but where do you think that best fits into people thinking about that? Do you feel like they should be doing that before was their launch the first version, or is that something you should start thinking about a little bit further down the road when you have more at stake?
Yeah, obviously, like it's hard to do the every single change every single time you deploy when you're like developing a new software, which is like it doesn't make sense. But the after, especially like after launching or like a certain scale, or if your project or software is like requires like more reliable, because for example, reliable or like availability is the one of the core feature of your software, then this is great, even if it takes time. And also they know, Amazon know that it takes time. So like they recommend the people to reduce the time for the change management by automation. As I mentioned, the like monitoring and alarming automatic stuff, that's the one step towards to reduce the change management process, because you already have the alarm and you already have the monitoring, so that you can easily detect the failure after the deployment, so that you can easily roll back. And even in the advanced pipeline, you can set the auto rollback with the like automatic monitoring, so that you can just push the button to deploy, and then we'll see. And if something goes wrong, computer automatically detect the failure based on your configuration of the monitoring, and then it will trigger the rollback automatically. So you don't have to do anything. So in this pipeline, or even sometimes they don't have to click, they just push the code and then automatically deploy. But whatever, you don't have to worry about the change management in this case, because like the pipeline is fully kind of protected by the computer. So I think that's the like ideal state every single pipeline pursue in Amazon, which is sometimes difficult. Simple application is fine, but the complex application, which is difficult to find the good monitoring and also the good like a rollback strategy for sometimes, because like you need to create a database schema, which is quite difficult or impossible to roll back. So in those cases, even if the pipeline is like a fully automated, they probably create a change management even though, and then the pause the automation and do it very carefully, because it's a risky operation, and they know and they can be aware of that by the change management.
I'm curious about, in those thinking about change management and structured rollouts in some capacity. More often than not, I work in, I do like primarily work in like web development, and we kind of tend to just kind of lean on pushing things out when they're ready. And we know there's some migrations and like database changes that might be happening and what have you. But there are scenarios where I don't know that I often see even like on my own team or teams that I talk to where they think more of like how they can roll out a set of new features over a period of time to like stage certain parts of the like, okay, we need to get some certain things in place so that we can, before we want to make some database changes, but we don't want to like have all of the UI change yet. Like let's get the database set up, have that work out there. It's going to take some time. We're not going to take advantage of these new database columns in the UI yet. I'm just using that as an example, but that will then need to be there in like a couple weeks when we ship that part of it. And so, have you seen, because I know that you work a little bit more on the orchestration and maybe DevOps side of things at time. Have you seen some good strategies for how to help teams or give teams a thought about how they might step through that process? Or is it typically more often than not, it's kind of like all at once type of thing or versus like a phased rollout?
Gotcha. Yeah, obviously the phase rollout is better than the big bang release for sure. So most of people try to do the phase release, but as you mentioned, like it's difficult to separate the code like in part. So most of the cases, and especially for the microservices, all the services to be upgraded to enable that new feature, for example, and each pipeline, each service has a different life cycle of the deployment, for example. So most of the cases they use the feature flag. So they implement the code and they ship the code into the production, but the first time it's like under the feature flag off, so that it won't be used at all. So it's pretty safe to deploy for sure because it shouldn't be used. And then this allows the team to trying the new feature in like a different life cycle of the regular deployment. So that means that you can try the new core feature on like a one account or one user on the feature flag and see what's going on based on the logs or like a monitoring, whatever. And then if you see something, they can roll back by turning off the feature flag, while you can still deploy a completely orthogonal new features on the regular pipeline, because the regular pipeline deploys the code, and as long as the monitoring is safe, or even if it's worse, you can turn off the feature flag and make it clean, then you can deploy the another code into the production, so you won't have to block the other components. And then every single team or every single a code base can do that. And once all are ready, then you can turn on the a feature flag, or sometimes they share the one feature flag by the multiple microservices, so that they deploy in a different life cycle. And once all the team deployed and they are safe to turn on the feature flag for the 10% of the user, turn on. And then all the microservices will immediately start to working on the new feature flag for the 10% of the user and see what's going on each side of the microservices. And if it's okay, then let me turn on the 20%, 30% gradually.
We'll be back with our interview with Ryosuke in just a moment. Hi, it's me, Robbie. I just want to take a moment to say thank you for making time to listen to the Maintainable Software Podcast. If you're enjoying these conversations and you're finding them valuable, please share a link to one of your favorite episodes in your team Slack channel, in your Discord channels, in some forum that you're hanging out, and maybe post it on Reddit. So this was a great episode. I enjoyed it. Or Robbie's a horrible interviewer. Also, do you know someone that maybe I should have on the podcast? Shoot me an email to robbie@maintainable.fm. And now, let's get back to our interview with Ryosuke Iwanaga. That's interesting when you think about projects like that at that certain scale where you have a high enough volume of activity and code changes that are happening, and trying to keep that stuff all together and making sense of coming up with good patterns for that. Definitely, it's a different world than I tend to work in, but it's something I'm kind of curious about. Can you talk a little bit about how teams should design for failure?
Design for failure, so everything can fail. Right? So everything can fail, including hardware. But as I mentioned, the people operation can also cause any kind of failure. So design for failure is the kind of core concept to make it maintainable and also the available and scalable. So think about the failure. That's the core concept. But in reality, everything can fail. So how can we manage that? That's the main thing you need to think about. So the typical example is like a multi-AZ architecture, so that you can avoid the one single AZ failure. So that's cool. But again, the failure, most of the failure caused by the human. So how to avoid that? And also the not the failure, but the scalability bottleneck can also happen. For example, AWS account. That's a good example. So if you share the one AWS account for thousands of the microservices or like a product, and then you need to spin up the too many EC2 instances, for example. But the AWS, of course, sure, they have some quota per account per region or something for the in terms of the number of the EC2 instances, for example. And you might hit some threshold quota, and then affect all the microservices, all the software, and they can't scale anymore until you get the a limit increase or something. So to avoid those kind of too many interference between services. And also, even inside the services, the cell architecture is the great strategy to avoid that kind of scalability and availability bottleneck. So the cell architecture is the state of the cloud, I would say, which is creating the application like a single, for example, the web application, just an example, but make it like a cellularized. So for example, user ID 1200 is on the cell A, which is the single standalone application, including load balancer, EC2 instances for the application, and the database. But the user ID 101 to the 200 will be in cell B, which is the completely isolated environment. And that's the cell application. So in this scenario, you can avoid the limitation per AWS account, for example, because you can use the different AWS account per cell. And if something goes wrong, not only for the hardware or a limit quota, but also the deployment, if you deploy per cell, deploy to the cell A first and then the cell B, if that's the strategy for the deployment, then if something goes wrong, a very bad deployment happened on the cell A, you can stop and roll back. And in that case, the affected number of the user are 50% because the cell B was intact because you haven't deployed it yet. So in this case, any disaster can only be shown by the 50% of the user. And as you have more cells, like 100 cells, for example, then the blast radius is 100, for example, if your strategy to first sell one cell first and then gradually scale. And that was actually the AWS strategy, because they have cells in the region, and also the region is of course the cell, it's isolated. So they typically deploy to the one region first and see what's going on inside that cell/region. And if it's fine in terms of the monitoring, then they ship the new code to the another region and gradually increase the number of the region, stuff like that. And so that the staged regular stage deployment. Yeah, so that's the kind of the a great strategy to avoid any kind of failure, because you isolated or siloed the application.
No, that's interesting. I wanted to ask you a little bit about cell-based architecture. And so for those unfamiliar with, I think a good way to describe that, you just mentioning regions, helped me wrap my head around it pretty quickly in terms of being we'll push this out to US West 3 first, and then later but that also gets into that scenario of for some teams that haven't yet automated all of the orchestration of going, okay, if it works well here, roll back if it's not. If there's an issue or something, if you don't have all that monitoring in place, I worry that some teams might be well, sounds like I might have to babysit a lot for every single time. And I'm we're going to do it here. How long do we wait before we go to the next one? And then we're going to do another deployment and then another one. If you have 3-4 different cells or regions, or whether they could be within the same region, potentially. But have you seen some effective strategies that help teams kind of think through that in a way that's not when you push things through a GitHub action? I don't know that everybody's thinking okay, great, now we're gonna have it run over here, wait a while, and then start the next one, and then wait a while. Are we talking potentially minutes? Are we talking hours between these different rollouts, or is it typical answer it depends?
Yeah, it depends. They typically like wait like a day or something in most of the cases. But so as you mentioned, as the number of cells or regions grow, it's pretty difficult to handle every single deployment of every single region cell manually. So the automated, of course, the pipeline and also the monitoring and also the dashboard as well are pretty important and like a companion with the cell-based architecture. Otherwise, it's just a disaster for in terms of the operation.
What about when like those types of projects, software projects where there's like, say it's a web application, but maybe there's some background processing things that all kinds of needs to be somewhat in sync. If you're sending like let's say there's a daily report that gets generated for all users, and then these different cells are off if you're waiting a day, and then the code changes are going to be different, or the report's going to be a little bit different for both of those user groups. So how do you kind of keep that to a minimum, or should you just target that to your specific cells? Or I think about that kind of thing being a little bit different than like a just like maybe like a UI change or something.
Yeah, but I think it's similar. Like, for example, yeah, different output might be expected, like in terms of the A/B testing type of thing. So that be okay. Yeah, and but if you want to really sync between the cell, then probably the feature flag, cross-cell feature flag, might be used as well if you want to really sync. But the general principle is to avoid any kind of shared resources between cells or between regions. Otherwise, today is fine. But like a few months later or like years later, it's kind of hidden like dependencies, and people tend to forget and then cause something pretty bad.
Well, in this set, I'm also wondering about like how different is this than say like a multi-tenant database situation? Like if you need to run queries across all of your regions, potentially to pull some reports or something, how does in a cell-based architecture, is the database is very much isolated and there's not like a global perspective? You just have to kind of somehow pull the data from say 4 different cells and then aggregate them together at that point, or are you able to do more of like a cross cell global snapshot?
The answer is it depends on the use cases and what you want to achieve. So if you want to focus on the isolation, then you should avoid sharing especially for the core business databases. They should be isolated. But the downside for this approach is, as you mentioned, that if you want to aggregate everything for some purpose, like reporting, or like simply you want to follow and follower stuff. Like if you isolate the user, then it's difficult to find the follower relationship across the cell. In that case, of course, one option is having a kind of shared database. But the another approach is creating the another component which access the like a cross cell, and then that component is the probably have a smaller responsibility like reporting, for example. So that component usually access the all the cells every day, sometimes with some like a retry and avoiding the too many query to the each cells, and they're trying to create a report across the cell. So in that case, the core component, core application business logic are still isolated, but the background logic are like a cross cell, and that the reporting application are like a different workload. So that's okay, and it's one cell, that's fine. But sometimes in that background process can't fit into like a single application size. In some cases, in like a large scale. So in that case, that application might also need another dimension of the cell in terms of I don't know, like resources or whatever. In AWS, some component has like a different cell even in the same region, like endpoints. So that's from the user's perspective, it's just a single endpoint per region. But inside the region, each microservice or each system has a different type of a cell to serve the available and the scalable system in terms of their business requirement.
Where did the cell-based architecture kind of pattern emerge from?
Yeah, I think so. Especially for the scalability, like the single horizontal scalability by adding the application server is the easy to understand to scale. But even with that architecture, you need the database, right? So then the database might be like a single bottleneck, and you need to, and then you think about how to scale the database. and you can use some like a horizontally scalable database. But actually, in that database architecture or service or whatever, they somehow need some kind of shared component to, for example, the metadata to how to route the request to the appropriate partition, for example. So yeah, so those kind of stuff arise in large scale organization, and it's never-ending story. And how to avoid that is a cell-based architecture. So cell-based architecture sometimes needs the the single endpoint, as I mentioned, to avoid the exposing the internal cell architecture to the customer. So that's the actually the cross-cell component, which might be a bottleneck. Design principle for the cell-based architecture is to make that cross-cell component, which might sometimes called the routing layer, to as thin as possible. The thin means the less metadata size and also the less business logic so that it's maintainable. And then delegate the heavy business logic application or like a large scale resources into the each cell. So that can be manageable and also the scalable in terms of the number of the cells, while you keep maintaining the thin routing layer so that it's still maintainable in terms of the size of the request.
I'm curious, what sort of technologies do you tend to work with to orchestrate all this? Like, what sort of what I'm just curious about, like, are you writing code or are you just clicking around, interfaces in AWS all day, clicking a bunch of drop down menus to try to figure this out and keeping it on your head? Because that itself sounds really complicated to maintain, let alone to design it and to make changes and understand how everything pieces together. Like, my brain's melting a little bit, to be honest. So what sort of technologies are you kind of leaning on for that? And
Yes, it's not a easy problem. Yeah, and that's the reason why AWS is succeeding because it's complicated, but they have some knowledge to apply to everywhere. But the one thing I would say is the kind of control plane, which is the routing. It's simple. You just look up the metadata and route the appropriate cell or whatever, which is pretty simple. But in reality, you might want to migrate the user from one cell to the other, for example, or change something, anything, or swap the EC2 instances, of course, or whatever, no matter the cell based or not. But the control plane is the kind of brain for those kind of workflows. So that's the control plane detect or monitor the application's behavior or some signal, and then do some workflow, for example, the migration. It might be triggered by the human operator or a reaction based on the monitor. For example, the S3 stores the data in a kind of a partition, and the partition doesn't have an infinite size, so eventually they might split the partition. So they have some kind of a threshold, and once the control plane receives that kind of signal from the metrics, then that will trigger the partition workflow automatically. And then the control plane monitors the workflow progress, and it might fail, and then that way they need to retry somewhere in a very careful manner. Otherwise, the data might be corrupt or inconsistent. So the design of the algorithm or the workflow is very, very difficult, and they need some kind of careful testing and design. But yeah, they use that's a way to handle those kind of pretty complex architecture to make it maintainable by the software. The human is impossible to migration migrating the user's record from one cell to the other by issuing the multiple SQL execution won't work, right? So you need to make it software and automate it, and also the test it, the review it, so that it's a kind of regular application. So that they have a control plane team who only focus on that control plane component to make it safer, reliable, and working properly, stuff like that. So the responsiveness is just for the control plane, for example.
Interesting. How do you define operational excellence?
Yeah, so that's the various way, but for example, the continuous deployment, I would say, with the monitoring auto rollback, which is great, and also the dashboarding and a regular dashboard review is also the good practice. So in AWS, it's kind of mostly the weekly review to see what happened in the past week in terms of the metrics, and if they see, Of course, the most of the metrics are monitored automatically and trigger some system alarm, but sometimes you see some like a trend which is not detected by the monitors, I mean alarms. And then you see something and then they might need to dig into that trend or some like a weird behavior to see what was going on. And sometimes it finds some like a critical bug or like a potential disaster by the like a single weird request, for example, and then you can tackle on before it happened largely. So like a regular cadence of the checking the healthiness of the your system based on the metrics using the dashboard is also important for the operational excellence.
Hey folks, it's me, Robbie. Just want to take a moment to plug my own company, Planet Argon. We're a software consultancy. Yep, Planet Argon, we're a software consultancy. What do we specialize in? Great question. You ask the best questions, listeners. Well, we help organizations with existing Ruby on Rails applications, predominantly, help make them better and more maintainable, hence the podcast topics. Are you surprised? Probably not. So if you know of a Ruby on Rails application that could use a little bit of help, get in touch with us. PlanetArgon.com. Again, that's PlanetArgon.com. Back to the show. So it's a matter of just ensuring that you have some regular cadence to have at least one person or a small group of people, maybe a large group of people, review the metrics, see how things are trending. So you're not surprised when something falls over and like, oh, why didn't we catch this 4 weeks ago? Or I literally had an email about a half hour before we hopped on this to start recording that from one of our clients that works with another agency, and they emailed us and another agency and they're like, why are our AWS bills 3 times more expensive than it was in January? And we're like, great question. What's different? And like traffic's been consistently flat. So we have some stuff to look into. The other agency does, but one of those things happen. And so we want to kind of avoid being surprised, I suppose. You mentioned like humans make mistakes earlier, and how when you're in panic mode and you're trying to ship out a quick hot fix or something, and that's when you're likely to potentially make even more problems for yourselves. But a couple of quick last thoughts for you. I'm curious if you have, in your experience, helped, you like a lot of these like kind of concepts are, I think, definitely for the listeners, they might be thinking, well, there's some people that I know that like listen, or I've had other guests that work at some large organizations like Netflix or GitHub and things like this. And I know that they're thinking about this sort of stuff, and I don't always get to talk with people like you about some of the complexities of just how all the orchestration stuff happens behind the scenes. But for those listening and like that are sort of curious to start like learning more about this, but they're like, maybe, they know how to log into AWS, or maybe they've made some, small configuration changes to like a Terraform or a Puppet or a Chef recipe or something, but they want to like start expanding their skill set there. Do you have any advice for them on how they can? Because then, like, I feel like unless you're part of a larger organization, I don't know how you get to kind of experiment with some of this stuff on a more micro level. So any advice for people?
Yeah, so the operational excellence is anyway important, no matter how the scale is. So that I think that one thing you can easily start, like creating the automated, sophisticated pipeline for your application, even if the application is pretty small or like a pretty simple. But making the comprehensive, monitored, and automated pipeline is not the easy task. Even in Amazon, I haven't seen a lot of people can do that. So it's great experience to learn about that, and that will trigger you to think about how to make your application like healthier in terms of this metrics, because this is like always like a bad, and you might need to dig into that problem and you might find something, and sometimes it's difficult to find the solution, and in that case you have like a problem, like a burning need on your hand, so that you probably have some kind of motivation to think about that problem. So you can dig into the internet or ask some like a staff engineer like me about, hey, I have this problem, but I don't have any good answer for that problem. And how do you feel about that? And then you might find something interesting, like a service architecture, for example. You probably have no idea about that before, but right now you have a problem, and then you might have a pretty good solution for that. And then you can apply if you want. So that's the one way to do. But the other way is just try to jump into the some level of the scale, and then you see in the some level of scale, you see like tons of problems around. So there is no need to think about what is the problem because everything is a problem. So you need to tackle something. And then you might need to think about the those kind of scalability stuff, and then soon you see that the service architecture or ownership or whatever might be needed.
Ryosuke, another question I was kind of curious about. Could you tell us a little bit about what your role is working in this space? Like, what is your current job title? What's that look like, and what other types of things are you kind of focusing on right now?
Yeah, so I'm right now in the full-time job is the staff software engineer in a startup company. I'm doing the like a pre-feasibility check from the technical side of view before we actually start the project, for example, and also even working with the business team to find like a new services, whatever. So that's kind of stuff, and also the architecture review for the other rest of the engineering team as well. So that's a typical software staff software job. But before that, I have like a multiple the roles in this industry, including, of course, the senior engineer, of course, but the other part of the software industry, like sales engineer for the AWS, and also the support engineer. And even before that, I like worked for the like a data center operation, like a physical operation, actually, to racking the servers, and also the like a database administration, stuff like that. So I had a versatile experience in this industry, yeah, and that all helped for me to do the current job because like a staff engineer need to have like a comprehensive view of the software system, business, application, whatever.
And I know you're doing a little bit of a consulting. Could you tell us a little bit about that as well?
Yeah, along with the full-time job, I'm also doing the kind of part-time job if I have some clients. So, which is the OpsVL. I created a company. The OpsVL is the operational bar raiser. So, bar raiser is the Amazon's terminology to provide some kind of third-party, not the authority, but the like providing the best practices to raise the bar. So I would like to raise your bar for especially for the operation because I'm good at the operational. But anything I can do that. So yeah, so that's the stuff I'm also doing right now.
Well, nice. Well, I'll definitely include links to your site and your LinkedIn and everything in the show notes for folks, and also to your article about cell-based architecture. I found an article that you had written not too long ago about that, so folks can learn more about cell-based architecture and about you. And with that, it's been such a delight having you join us on Maintainable, Ryosuke. Thank you so much for stopping by to talk shop with us.
Thank you so much.